I am a senior year undergrad student from University of Borisal, Department of Physics. I have worked with three of my professors from my university and other from GOLN. So if we make a closer look in our title, then we will see that there is a molecular transport. There is a molecular transport through a single nanopore in the lipid membrane by the electroporation using Thomson physics. Now, this is in, the bar in the circle. About the circle is the electrode, and the circle is the giant unilamellar vesicle. And the transport, this is the pore, and the transport will happen in such a way from outside to inside. And this is our outline. We will start from introduction, and finally we are finished with the outcome and the word. Introduction is the cost of human treatment in Bangladesh is costly, and the process of the treatment was more sophisticated. In those sophisticated levels, but there is no development in the simplification. Here is the cancer statistics in United States, which is available in Google. In 2000, the cancer chemotherapy cost was 20,000, and in 2022, it was 9,000 after applied sub condition. And the deaths in 2000 is over 500 and 5 lakh and 5,000, 50,000, and in 2022, it's over 6 lakh. And here is our motivation: is the cancer disease are highly prevalent in Bangladesh, and around 1.5 million people in Bangladesh are currently patient in cancer, and about 1.5 lakh people died every year from daily study. Now some existing work. Here is the treatment. Here is the simulation of inside to outside for multiple nanopore. And here is the simulation of molecular transport of electroporated normal cell, where inside to outside to inside was happening, but this cell was not giant unilamellar vesicle, and they were not made the exact experiment which was needed for the cancer treatment. And existing parameter definition is irreversible transformation, electroporation. Irreversible electroporation is some type of electroporation where cell will die or damage, but it will not recover very soon. And the voltage we have applied was 5 kilovolts. And the cell membrane will damage. And if we make the time duration large, then the cell will damage properly or die. Let's try some basic concepts. We all have known this is the bilayer of protein and lipid of a cell membrane, and in the right image, the electrode where the transformation is happening. Now the vesicle and its classification. There are 3 types of vesicle. We have used giant unilamellar vesicle, and in the right side, here is the giant unilamellar vesicle. And we have used Oram 79, where in the cell electrode, where gold electrode is worked to make a circuit around the cell. Our research objective is first running the console simulation for observing molecular transport from outside to inside. Second, compare the simulation result with the experimental component. And finally, understand the mechanism of pore formation. First, we have used AutoCAD for designing the giant unilamellar vesicle. The diameter of giant unilamellar vesicle was 5.004 micrometer with nanopore and electrodes. And second, we have examined all the experiments in Thomson multiphysics in 2D space, where 40, 60, and 90 micrometer square field was used to make experiments. And finally, we have experimented all the data through Origin Pro 2022. Now, first we are designing the giant unilamellar vesicle. Second, designing the geometry of buffer area. Third, we are running the simulation through Thomson multiphysics. Fourth, we have specified the output data. And finally, we have analyzed the data through Origin Pro 2022. Now first designing the nanopore of the giant uniluminar vesicle. This is the zoom image of the giant uniluminar vesicle, and the right bar is the nanopore of the giant uniluminar vesicle, and this is the membrane. It is outer side and it is inner side. Now, if we make the experiment, then this type of mesh will happen in complex multiphysics. And at the time of 0 seconds, the concentration in the inner side is 0. That's why it's blue color. And the concentration outer cell is 1 at the time of 0 seconds. And after the experiment starts, the concentration in the inner cell, giant uniluminar vesicle, will increase. And after it's gone, it is at the final time it's gone such like that, where the concentration of the inner side and outer side is equal to 1. And this is the graph of the inner side. At the experiment start time, the concentration is 0, and finally it extends to 1. Now some experimental results. For time t equals 0 seconds, the 4 nanometer pore, the 8 nanometer pore, 16, 32, and 64. At time t equals 0 seconds, the concentration in the inner cell is 0. And time t equals 30 seconds, the concentration in the inner cell is increasing. And in the 64 nanometer pore, the concentration is larger than that of 4 nanometer or such type of. And 26 nanometer is such type of, and 40 seconds, the inner concentration and outer concentration is equal. And we will analyze this data for 4 nanometer, 16 nanometer, and 64 nanometer for simplified. The concentration for square bar, triangle, and round circle. For 4 nanometer pore, the circle is shown, and for 16 nanometer pore, the triangle is shown, and for 64 nanometer, the square is shown. The concentration of the square is the largest, and the concentration of the 4 nanometer pore is the lowest. At t equals 0 seconds, the concentration is strictly 0, that is seen. And after it increases, after time increases, the concentration is increases. And at one time, the concentration of 64 nanometer pore is larger than other two. And in the final session, the concentration of 64 nanometer is the largest, but all the same. It about 0.001 mole per meter cube exchange or something. In the concentration of the 4 nanometer, 16 nanometer, and 64 nanometer phase to 1, which is in the right of the graph. And the concentration of 64 nanometer is slightly higher than other two. For different time sessions, we have taken 40 nanosecond, 40 seconds, 80 seconds, and 120 seconds. And for 120 seconds, the concentration is the largest among the two. The concentration in the inner side is the highest, about 0.9986 and dot. The concentration of 120 seconds is the largest among the two. Now the concentration is 0, and at the time of 0 seconds, and it increases for the 40 seconds, the concentration is about 1 mole per meter cube. And there is a slight difference of concentration due to different size of area. And finally, we have got the area for different parameters for different suspension area types for 40 micron, for 60 micron, and for 90 micron. The concentration is different. For 40 nanometers, for 40 micron pore, the square is shown, and we have seen that for 40 and for 60. The concentration is start to end is equal, but for 90 micron pore, the circle is not equal. The smallest area is the lowest concentration for the 40 microns. And the 90 micron, which is the largest, is counting from 0.5 mole per meter cube area. Here are some key outcomes. And finally, we have gone to the conclusion part. We have seen that the larger the pore size, the laser time is need to expand throughout the GUV. The more time, the laser time is need to make concentration of GUV to 1. The less the time, the less the concentration, and the more the time, the more the concentration. For the suspension area, the larger the suspension area, the concentration will go in phase to 1. And finally, we have got that we can easily determine what type of pulse we should use, that is less than 5 kilovolt or higher, and what type of time we should use, that is 0.01 nanosecond or 0.1 nanosecond or 1 nanosecond. And we can introduce, and we also determine that what type of pole we will use in the skin, and what should be the experimental area of this skin, and how much time it need to introduce the drug in the cell. And here are some future work we work on each, and finally they are the references.
Thank you very much for question answer in the time of explanation. I request you to make the session interactive. So if you have any question or any kind of explanation, please. Sorry, or any inquiry you can ask the author. This paper, actually in previous paper, that was like detection. First paper, so in this session there was another paper that is related to detection. So this paper is related to the treatment. Yeah. So in actually really results variation of types of 4, 16, and 64. Shown some data on the variation of type. Finally, let's go to the conclusion slide. There we can also the conclusion is that now it will be easier to choose the pulse needed for treatment. To explain this issue, how the doctor will choose the pulse size or type of pulse needed for the treatment.
Sometimes the pulse is more higher, sometimes it is low. Sometimes we need to deliver the drug, as long as we need damage the cell, and sometimes we make the cell dead. So for that issue, we have made different type of pulse to examine which type of pulse we will need.
So I have seen references.
We have used for experiments and for our exterior what we will use and for that type of experiments.
But result is not so straightforward. So that's why I think maybe more standard to make some point. And also in references, I show regarding mention about the date. Yeah.
Yeah, I have all the references, but I have not given because work complex. So I have can't go
This year or previous year or near to mention. And this is a very actually critical study. So make some comments it must have to recheck this is very critical issue will be applied to some. So it's a very critical issue. So after all, thank you very much for watching. Thank you.